So now we're going to shift our focus to our discussion of renewable resources. When we talk about renewable resources, we're talking about energy resources such as our bioenergy or biomass energy, our hydropower, wind, solar, geothermal. We also put hydrogen fuel cells into this category as an option. These are the sources of energy that we consider to be renewable, that will be around for the long term, that won't be exhausted, certainly in our lifetime, like fossil fuels. And like with uranium, we think that that's going to be something in terms of nuclear power, that as much as we have a lot on the planet, it is not something that's going to be here over the long term. As we talk about renewables, we're going to talk about the pros and cons related to each type of energy resource. Keep in mind that there is no single source of energy at this moment that we think is the end-all be-all, that it's the one that we should just convert everybody to, and it's going to solve all of our energy needs. So just keep that in mind. As much as we think renewable, we think they're the perfect way to go. It doesn't mean that every source of energy is applicable in every application. So we have to take each one by one and kind of evaluate where they kind of fit into our overall energy picture. You'll see here on this slide that about 9.4% of the energy that we consume here in the United States comes from renewable sources. Only about 10%. You'll see that about 80% of it still comes from fossil fuels. And as I said before, I expect this renewable picture to grow. I expect the fossil fuel picture percentage to decrease. Nuclear power, we anticipate, is probably going to stay at the same level in terms of our overall picture, because we don't see a big area of growth at this current time here in the United States. But I expect this renewable area to grow. Within that renewable area, there is going to be certainly areas that will grow faster than others. In terms of bioenergy, I don't expect a huge increase there. And we'll talk about the different types of energy that fit into that category. Hydroelectric power, again, sitting there as about a third of our renewables that we use. Not really growing for multiple reasons here in the United States. That is going to remain what we're using pretty stagnant. Wind and solar we see as the biggest areas of growth. Wind growing very rapidly here in the United States. Solar right behind it. And geothermal has a piece of the puzzle there, but is a small percentage for various reasons as well, in terms of location, for example. So we'll talk about all of these individually. We'll talk about tidal or ocean resources as power, as a potential source of energy. And we'll also kind of fit in our last conversation in energy, we'll talk about hydrogen fuel cells and kind of how they fit into this picture of renewables. So how do renewables fit into our electricity generation here in the United States? Again, I mentioned that we do still use coal as a big part of our electricity generation. So you'll see our fossil fuels still up there at 67% or so. Nuclear power almost at 20%. We know up in Michigan we use nuclear power from Cook, Palisades, nuclear power plants for our energy. In Indiana we still use a lot of coal for electricity generation. So even locally we see our picture similar to this, where we rely mostly on fossil fuels and nuclear power. Renewables at only about 12% of that picture. Again, I expect that to increase. I expect fossil fuels to decrease over time. And you'll see obviously that we looked at earlier with hydropower being a big part of that renewable picture, that I don't anticipate is going to increase. But we see that wind power at about a third of our renewables for electricity, and we anticipate that's going to increase. Solar will increase. Bioenergy, again, we'll talk about kind of why we think that's not going to be a huge area of increase, in geothermal as well. So we'll kind of look at kind of where they fit into this picture across the United States, what's applicable where and why. There are a lot of reasons why we think, when we think about renewable energy, we think positively. And one of the big ones, and for most of our renewables, this applies, we think about the concerns related to climate change and greenhouse gas emissions. So in this graph, you'll see our renewables at the top, our non-renewables at the bottom. Clearly, we know that anytime we burn something that's organic, we release carbon gases. So our concerns are related to carbon dioxide and methane gas. So we see natural gas, oil, and coal there. We see how coal is clearly the dirtiest in terms of carbon emissions. Oil's in the middle. Natural gas is the cleanest. It's not clean, but it's the cleanest of those three. And then you see nuclear power way down low because of, and we know this because we don't think about air emissions from the use or the generation of nuclear energy. So you see that, in terms of a carbon picture, our non-renewables, specifically our fossil fuels, are our big concerns. When we look at our renewable pictures, we think about, generally speaking, that is not really a big concern. Possibly when we produce these, whether it's, wind turbines, aerogenerators, when we produce solar panels, photovoltaic cells, there may be fossil fuels involved in the production of these things and certainly the transport of these things. So they're still part of, still contributing to that carbon concern, but not to the extent of the fossil fuels, where not only are we transporting them in a lot of cases, but then we're lighting them on fire and releasing all those carbon gases, which are greenhouse gases and contribute to our climate change problem. So that is one big advantage. The one that kind of stands out in terms of renewables as a concern related to carbon emissions is biomass, and that is because we're talking about organic matter as well. Okay, it is renewable organic matter, but it is still organic matter, and therefore it contains carbon. So when we do light these materials on fire, whether it's ethanol, whether it's biofuels, we're still going to be contributing to that climate change concern. Okay, we're still going to be releasing those carbon gases. So that's why you see that kind of a little bit more there in that renewable spot on your graph, but still significantly lower in our overall picture than our non-renewables. So again, a big advantage, generally speaking, for renewables over non-renewables. But like I said, as we enter into our discussions of each individual type of power, we will talk about what's good about it, and we will talk about what are the drawbacks to each of those. Okay, so keep in mind that when we talk about renewables, we're talking about resources that we believe are inexhaustible. Okay, that they will create less pollution. They can help our economy. It can decrease our dependence on foreign countries for energy resources, decrease our oil imports. We've tried to kind of shift to renewables, but there are a lot of challenges. Okay, there's less subsidies, fossil fuels are cheaper, there are some technology barriers and political barriers, economics, to making these shifts. Okay, our infrastructure is built around nuclear and fossil fuel technology. So it's difficult, okay, to make shifts to these renewable sources of energy, but we're making progress in different ways. So keep in mind as we talk about them, we'll kind of talk about what the type of energy is, and then we'll focus on kind of what's good about this source of energy, and what's bad, what's not as good, or kind of the negatives involved. Okay, so when we think about bioenergy, we think about something living, okay, getting energy from something that's living, okay, and basically we're thinking about burning organic matter, okay, and we, like I said before, we differentiate this from fossil fuels, because fossil fuels are something that's been around for millions of years, okay, that took millions of years to form, and organic matter, if we're talking about bioenergy, we're talking about a renewable. So something like corn. We can just grow more corn, okay, and that can be seasonal. We can grow that every season. I should say, yearly. Every corn season, every summer into fall if we want to. Okay, switchgrass, etc. These are things that we can grow back. Algae, okay, in the lab. We can just keep growing them relatively rapidly compared to our fossil fuels. Okay, so things like fuel wood, okay, our trees we can grow back, using waste products, okay, that are organic. We can use crops, like I said, corn or switchgrass, like you see in your pictures there, or bamboo, sugar cane. Okay, and we can burn and capture the heat from these different sources of biomass to generate electricity, power cars, etc. Okay, so there's a couple different types when we think about bioenergy. The first one is ethanol, and you probably heard about ethanol. There's a plant in India. I know there's a plant in South Bend, Indiana, an ethanol plant. And basically what happens is we use corn, which we produce a lot of corn. We ferment it, okay, using fermentation method like anaerobic respiration. So kind of basically having these corn fermented, okay, by other organisms, and we can produce alcohol. Okay, so basically, taking this kind of corn sugar, fermenting that, using other organisms to produce an alcohol. Okay, and again, when we think about ethanol, we're talking about an alcohol. And what we commonly think of here as ethanol is our E85. So if you drive up to fill up your car at the gas station, you'll see an E85, okay, where basically it's 85% ethanol and 15% traditional gasoline. So basically that ethanol is derived mostly here in the United States from corn. It's corn ethanol. And that's kind of the proportion. It's called E85 because it's 85% ethanol. And cars or trucks that are able to do that are labeled as flex fuel or able to take E85. So you may have heard of that. In Brazil, for example, they ferment sugar cane, okay, because they grow a lot of sugar cane there. So again, there are good things about this, and there are bad things about it. Okay, and we'll talk about them in a minute. The second type is biodiesel. Okay, so you may have heard of this as well. I'm using waste products like old vegetable oil, used cooking grease, animal fats, rapeseed oil, soybean oil, etc. Okay, so what else are we going to do with it? Throw it out? Okay, so why not use it as a source of fuel? Okay, scientists are working on additional fast-growing crops, wheat, cassava, hemp, algae, different things that we can use and grow quickly and regenerate quickly and use as fuel. Okay, so why not use it? Okay, instead of incinerating it or landfilling it. Okay, using it as a fuel. Okay, so bioenergy sounds like a pretty good deal. Okay, we certainly could be very energy independent, okay, if we used ethanol, because we can produce a lot of corn, and we can produce a lot of switchgrass, and we can grow algae, and we can do all these things in the lab, or on our, in our ag fields, and we can ferment them, and we can produce these fuels, okay, or we can use our waste products. Okay, this sounds like a really good idea, and there are some positive aspects. In this slide, I just put this image up to remind us that in the developing world, we still use fuel wood as a primary source of energy. We think about just using it maybe in our fireplaces. Some people still heat their homes here in the United States with wood, but we have shifted away from using this fuel wood to using our fossil fuels and other things for our power generation. Okay, so if we think about positives of bioenergy, okay, we said we can produce these easily and they're renewable. We just grow more. Okay, so that's pretty sustainable. And we really need to move towards sustainability. So this is a really good thing. Okay? When we think about these things are biodegradable. Okay? So they're less toxic, okay, than traditional petroleum, for example, that we extract. We can become less dependent. We could do less fracking, okay, and then, have those negative impacts that we talked about before. Okay, so we like the idea of renewability. We like the idea of having things that are non-toxic, biodegradable, okay, less emissions compared to petroleum. But there certainly are concerns and negatives. Okay, clearly if we're going to be growing things not for consumption, so we're not going to use this corn for consumption, okay, that can cause kind of a shift. Okay, first, economics. So when farmers started to shift from producing corn for human consumption or animal consumption to producing corn for ethanol production, okay, the price of corn for food and feed went up, okay, because there was less supply of that food for people and animals, okay, because of the shift to people producing corn for ethanol production. So it drove up the price of corn. So again, economics plays a part there. If all farmers, if a lot of them decided to make this shift, okay, it would drive up the price even more. Okay, clearly if we're going to be, growing more of these plants, for example, like corn, we'll probably be using more pesticides, fertilizers that could have negative impacts on fresh water. Okay, if we are creating kind of a monoculture of a certain type of corn for ethanol production, that can degrade the land. Okay, we do not like monocultures. Okay, they are much less stable than areas with biodiversity. We like to, rotate our crops and give land breaks and have different types of species growing on lands at different times in order to keep that land healthy and sustainable. Okay, it uses a lot of land. Okay, so if we are going to be growing corn, it does use a lot of land. And again, we use a lot of fossil fuels to run farm equipment, etc. Okay, so we use a lot of energy to get a lot of energy. So it's kind of a drawback. Okay, it's not carbon neutral. Okay, we use fossil fuels to produce, and in addition, okay, remember that these sources of energy are all organic. Okay, and since they're all organic, they all contain carbon. So when we light anything on fire, okay, something direct, ethanol, it's going to release carbon. We burn vegetable oil. Guess what? It's going to release carbon. Okay, so this does not solve our problem of carbon emissions and climate change and global warming. Okay, it doesn't, it doesn't help us in that situation, and that's one of the main reasons why we feel like we need to divert away from using fossil fuels, is because of the carbon component. And bioenergy does not solve that problem. Okay, it solves our sustainability in terms of energy problem. It probably could do that. Okay, but what is the cost involved in that? How can we burn it cleaner? Okay, and that still is a problem we continue to have with burning any organic matter, whether it's 1 million years old or it was grown last year. Okay, it doesn't matter. If it contains carbon, carbon gases are going to be released, and unless we fix that, okay, and figure out how not to release those carbon gases, it might kind of be DOA, okay? It may not be something that will continue to develop more unless we find a better way to clean it up.